Let's continue with our question 4. So we are moving to question 4b right now. Question 4b. So question 4b is saying that we should calculate the value of k for which the sum of the first 10 terms of the sequence is 535. So that means the meaning of this is that we are to, okay, let me first rewrite my use of n as 3 brackets, oh, excuse me, that's k bracket 3n minus 2 minus n plus 1. So the meaning of this question is saying we should add the first term plus the second term plus the third term plus the fourth term and so on up to the 10th term, and that should be equal to 555. So we are asked to find the value of k. Now, instead of wasting my time finding use of 1 up to use of 10, I can just apply sigma notation. Sigma notation of use of n should be equal to 535. So, but I need to know my counter. This is starting from 1 up to 10. So that means it's starting from when n is equal to 1 up to 10. That is my counter. Now, this can be simplified by substituting use of n. This is use of n from the top. I have to put it in my sigma notation equal to 1 up to 10 of the given use of n, which is k bracket 3n minus 2 minus n plus 1. So that should be equal to 535. So from there, I have to distribute this because sigma notation, one of the properties is that it is distributive. Let's distribute it. But before that, let me open this inner bracket. Let's open the inner bracket. Sigma from n equal to 1 up to 10 of k times 3n. That's 3kn minus 2k bracket minus n plus 1. So, excuse me, minus n plus 1 equal to 535. So now the next thing is to distribute the sigma notation. So that means all in all we are going to have 4 terms generally. We are going to have 4 terms generally. So we can just, okay, well, we can still we can combine this and this together to have sigma from n equal to 1 up to 10 of 3kn minus n minus 2k plus 1 close the sigma 535. Now, this is common. N is common here. We can still factor it out. N equal to 1 up to 10 of 3k minus 1 bracket n. So n is common minus 2k plus 1 all equal to 535. Then I will now distribute the sigma notation. Let's go. Let's distribute the sigma notation. We have sigma from n equal to 1 up to 10 of 3k minus 1n minus, I still have to distribute it to this sigma 2k from n equal to 1 up to 10 plus sigma n equal to 1 up to 10 of 1 equal to 535. So that's sigma notation. Now, the whole of this, 3k minus 1 is a constant, I can bring it out. So I have 3k minus 1 sigma from n equal to 1 up to 10 of n minus 2k is also constant. If I factor out 2k, then it will remain 1 inside here. So I will have 2k sigma 1 from n equal to 1 up to 10 plus sigma from n equal to 1 up to 10 of 1, which will give me 535. Now, I have to recall some formula for sigma notation. For instance, sigma let's recall sigma from n equal to 1 up to r of r, which is the sum of natural numbers natural numbers starting from 1 up to the term r, which we don't know where it ends. This can be given as r bracket r plus 1 all over 2. And also sigma from n equal to 1 up to r of 1. 1 is standard. So that will give me r times 1, which is going to be r. So the meaning of that is that anytime I have natural numbers, when we are adding them up to an unknown term r, I have to say r bracket, whatever r is, I'll put it plus bracket r plus 1 all over 2. So, but for this, from n equal to 1 up to an unknown term r, I have to drop the r, that is r times 1. So we can apply this in this given formula. Therefore, that means sigma from n equal to 1. That means therefore sigma from n equal to 1 up to 10 of n will be given us. So now my r here is 10, where n is 1, my r is 10. So that means whenever I see r in this formula, I'm going to put 10. So I will have 10 bracket 10 plus 1 all over 2. So I can drop these 2 here 1, 2 here 5. So that means I'll be having 5 brackets 11, 5 times 11, which will give me 55. So follow me, let's go to the top. So I will have sigma, then the other one, which is sigma. These ones, I can also sigma from n equal to 1 up to 10 of 1. That will give me, since they said sigma from n equal to 1 up to r of 1 is 1, then that means this one too will give me, so my r 10 is in the position of r, that will give me 10, ordinary 10. So I can substitute this and this in the above formula in this equation. Let's call this equation 1. Let's keep it. So we can put these values, these two values, in equation 1. So that means I'll be having 3k minus 1 of sigma from n equal to 1 up to 10 of n minus 2k sigma from n equal to 1 up to 10 of 1 plus sigma from n equal to 1 up to 10 of 1 equal to 535. Then I can put this. So I have 3k minus 1 times, what's the value of this? Sigma from n equal to 1 up to 10. That's 55. Let's put 55 here. That'll give me 55 minus 2k minus 2k, excuse me, minus 2k times sigma from n up to 1, that's 10, times 10 plus another 10, equal to 535. So now, I have to open this bracket. This 55 will affect the bracket. 55 times 5, that's 165k. 165k minus 55 minus 2 times 10, that will give me 20k plus 10 equal to 535. So at this point, I will have to collect like terms. This and this can come together or go to the back. That's 165k minus 20k equal to 535 plus 55 minus 10. So we can combine this. 165 minus 20, that will give me 145k equal to 555. 535 minus 55. 535 minus 55. That will give me 480. That will give me 480. 480 minus 10. That will give me 470. And that's it. So let's use calculator for that. 535 minus, excuse me, 535 plus 55. That will give me 590. 590 minus 1. That will give me 580. That's 580. So 555 plus 55 minus 10. 580 for confirmation. Then we have to divide both sides by 145. Divide both sides by 145. That's 145k divided by 145 equal to 580 divided by 145. So K will be equal to 580 divided by 145. That will give me 4. So the value of K is 4. So this is the end of question 4B, and that means the value of my K is 4. Thank you for watching this video. Kindly subscribe to our YouTube channel and follow us to the next question, which is question 5 of the last NECO exam. Then we are